Hi everyone, we are team number 6. Our group is formed by Julian, Camilo, and who is talking to you, Angie. We are taking the SCADA course as part of our degree project. Okay, so I am Angie Coronado and I am currently studying the undergraduate program in mechanical engineering.
I am Julian Hernandez. I am currently studying the undergraduate program in mechatronics engineering.
I am Camilo Rodriguez. I am currently studying the undergraduate program in mechatronics engineer.
So this is our first challenge. The aim of this challenge is to show our skills developed in the first 6 weeks of classes. We have created a simulation on the buffer station environment from Factory I/O and designed a PLC logic on Studio 5000 Rockwell. This scene is composed by 2 conveyor belts and a box dispenser. The boxes come from the dispenser through the first conveyor belt. The number of boxes going through this belt depends just on the size of the boxes and the length of the belt, whereas on the second conveyor belt must pass just one box at a time. For this, there is a sensor located at the end of each belt. Between each belt, there is a barrier that will be activated to stop the flow of the boxes from the first to the second belt. At the end, there is a slope that will carry the box to its arrival point.
In this simulation, we can see how in the control panel we have several buttons. We have the start button, the stop button, the reset button, the emergency stop, and a display that show the number of boxes that arrive at the end of the line. It should be added that the stop button is no longer illuminated when the start button is pressed and start to illuminate. Um, Pressing the start button will start the movement of the boxes, so the simulation starts and the boxes move along the first band. At the end of the first band, there is a sensor that detects the passage of the boxes. At the beginning, a first box passes to the second conveyor without problem. Then, when a second box passes to the sensor, it causes that the conveyor belt to stop and activates a blade that stops the boxes for passing. When the first box passes through the sensor at the end of the second band, the passage of the boxes of the first band is resumed. When the stop button, with the stop button, the simulation is paused and we can resume by simply pressing the start button. Additionally, the sensor on the second line counts how many boxes are counting out. This counter is reset each time the reset button is pressed. Finally, we have an emergency stop, which, like the stop button, stop the simulation, but it's different from the normal button, the normal stop button, because it remains locked and can only be used to continue the simulation if it is pressed again. In other words, it is unlocked.
The logic was developed in Studio 5000. As you can see, we have an emergency stop button that stops the whole machine in case of emergency. This button, in real life, is normally closed, so in the ladder logic, we must place it as a normally open connection so that when a Boolean 1 comes from the simulation, here it is also represented as a 1, and when we press it and it opens, representing a Boolean 0, it is a 0 in the logic and it stops everything. This also happens in the normal stop button. The difference is that the normal stop button is a push button, and when it is released, it returns to its closed state, while the emergency button, once pressed, it is necessary to return it to its initial state manually. This for safety reasons. Then we have the start button that starts the simulation and activates the status on. As long as the status on is true, the status off must be false. Next, we have an interlock circuit for the buffer conveyor belt represented as the KM1 contactor. This band is activated when status on is true, and when this variable called letbox pass is true, which I will explain later. Then we have the second conveyor belt that is activated when the status on is true. Now we have the blade control that is activated when the letbox pass variable is activated and the status on is true. Otherwise, it will interrupt the passage of boxes. Now we have the most important part of the logic, and that is how we decide whether to let a box pass or not. For this, we use two counters. One that is activated with the sensor called addBufferExit, and the other with the one called addExit, and they count how many boxes pass. The preset of these counters doesn't interest us, since we do not want to count a maximum number of boxes, but we are interested in the accumulated number of each one. Because by comparing them, we can decide when to let a box pass or not. For example, once a box passes completely in the add buffer exit sensor, the counter increases by 1. But as this box has not passed the add exit, then the first counter is higher than the second one, and therefore we will not let more boxes pass. When the send box passes, the second sensor and the second counter will equal the first one, and we will let the box pass. Finally, we have the display counter that shows how many boxes have been shipped, and a reset for this counter. And we also have a reset for all the simulation counters, which is triggered by the simulation reset. This is because when we reset the simulation, things happen that do not happen in the real world, like all boxes disappearing from the simulation, so the program can go a little crazy in this situation. But with this option, every time we reset the simulation, we make sure that our program in the PLC also goes to its initial state and everything works in a coordinated way.
A programmable logic controller allows us to control machinery in order to automatize processes that aim to increase quality life of workers and make easier controlling the variables on specific points of the production lines. For us as engineers, it's important to know the operation behind an automated production process, and even more important, have developed the skill to design the logic behind a PLC. This shows us that we are capable to take these technologies and apply them on a huge spectrum of industries, not just on production and manufacturing process, but also on the control of refrigeration systems, boilers, air conditioning, security, and among others.
In this first challenge, we integrate several concepts learned in class, such as connection and configuration of a PLC and its components, connection to a digital twin through OPC communication, handling of ladder programming such as open and closed contacts, interlocking circuits, coils, counters, among others. And we managed to integrate everything in a small project to demonstrate its operation. Thanks for watching our video. Stay tuned for a second challenge and our final project. See you soon.